Today we're going to be looking at how to graph absolute value functions. Now, absolute value functions typically in the study of mathematics are grouped together with linear functions, although they are not entirely linear. They are not a straight line from one side to the other, but they do share a lot of the same characteristics. So let's look at linear functions in terms of the parent function. Our parent function here is simply f of x equals absolute value of x. Now if we go to graph this, easy way to think on this is in terms of a table of values, x and y. And I'm going to take my table from -2 to +2, counting by ones. This is a continuous function, so all the values in between are valid, just this is easy for the purposes we have. So if I take the absolute value of -2, I get a +2. Absolute value of -1 is +1. Absolute value of 0 is 0. And then I get 1 and 2 again as I continue out the rest of my table. So that means my function will have a point at -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. If I connect these on either side, to the right, I move up, and to the left, I'm moving up. I end up with this shape of a graph as my parent function. Now the vertex form will take on the appearance of f of x equals a times the absolute value of x minus h plus k, where my vertex is located at the point hk, or more simply put, whatever it takes to make inside of the absolute value set 0, and then whatever is remaining outside is going to be the location of that turning point of my function. As you notice from our parent function, nothing is inside here, so 0, we'll move it left and right, and nothing's being added to the end, so 0, 0 becomes the point of that vertex. So how can we use this as we look at other types or other members of this function family? Let's take a look and practice graphing several different absolute value functions. So on here, we are going to graph three different functions. We have our first one being g of x equals the absolute value of x plus 2. Now we can build this with a table of values, x and y. First, what does it take to make inside of the group 0? And that would simply be if x was 0. Then I'm going to pick 2 points on either side of it to help build my table. So if I use 0, absolute value of 0 is 0, plus 2 gives me a result of 2. Now if I use -1, absolute value of -1 is 1, plus 2 gives me a value of 3. -2, so absolute value of -2 is 2, plus 2 is going to be 4. Substituting in the 1 and the 2, because the absolute value will take on the similar features, and I will have again 3 and 4. So my g of x equation will have -2, 4, -1, 3, 0, 2, 1, 3, and 2, 4. So if I graph this line, or this absolute value function, I have this, which is my parent function simply moved up 2 units. And this 2 is a k value, which affects my vertical translation. So everything is matching. Next, let's take a look at the h function. I'm going to build my table sideways for convenience of space. X on top, y on bottom. And we have to start with what does it take to make inside of the group 0? Well, if x plus 3 has to equal 0, then x must be a -3. I'll pick two numbers to the right of it, -2 and -1, and two to the left, -4 and -5. So if I start substituting in Negative 3 plus 3 is 0. We already established that, and that's all we have, is just that 0. If I put in a negative 2, negative 2 plus 3 is a positive 1. Absolute value of 1 is 1. Next, using negative 1, negative 1 plus 3 is 2. Absolute value is 2. Moving to the left, negative 4. A negative 4 plus 3 is negative 1. When I take the absolute value, I get 1. And using negative 5 plus 3 is negative 2, whose absolute value is 2. So I get the points negative 5, 2, negative 4, 1, negative 3, 0, negative 2, 1, and negative 1, 2. So tracing this out, connecting the dots and extending, I end up with a function that looks like that. It's the same as my parent function was, simply moved left 3. And that is what my h value inside of the absolute value states. Next, if I take my j function, what does it take to make inside of the group 0? And that is a positive 4. So I'll go 2 and 3 to the left, 5 and 6 to the right. So if I put in the negative 4, or put in the 4, 4 minus 4 is 0, absolute value is 0, minus 1 is negative 1. If I use 3, 3 minus 4 is negative 1, whose absolute value is 1. 1 minus 1 is 0. If I use 2, 2 minus 4 is negative 2. Absolute value is 2 minus 1 is 1. If I substitute in 5, 5 minus 4 is 1. Absolute value is 1 minus 1 is 0. 6 minus 4 is 2. 2 minus 1 is 1. So I get points at 2, 1, 3, 0, 4, negative 1, 5, 0, and 6, 1. Connecting these points and finishing out the graph, I will end up with a function that looks relatively like this. This one has been moved right 4 and down 1, which matches our h and k values. So we've gotten a lot of work with our translations about the plane. Now let's look at what it takes when we have some multiplication and vertical stretching happening. We're going to work out the same way that we had. We'll start with our function, our x and y. Inside of the group, we need a 3 to make it equal 0. 3 minus 3 is 0, times 2 is 0, plus 5 is 5. So my vertex, I can quickly learn to locate is what does it take to make inside of my absolute value 0 and what's being added to the end. So even plotting this point to begin with at 3, 5, I'm going to start my graph here. Now, as I pick numbers 4 and 5, 2 and 1, we'll see the results that happen. 4 minus 3 is 1, absolute value is 1, times 2 is 2, and 2 plus 5 is 7. I will be off the end of the graph, but just so we work through it, 5 minus 3 is 2, 2 times 2 is 4, 4 plus 5 is 9, which would put me very high up. Next, if I use 2, 2 minus 3 is negative 1, absolute value is 1, times 2 is 2, plus 5 is again 7, and then if I ran the number 1, I get 9. So I end up with a function up here in the top corner that looks like that. It's very similar to the other ones, translated of course, but now it has a vertical stretch of being 2 times as tall. Our slope on either side is effectively 2. Next, if I try it for h of x, building my table, x and y, I will get negative 1 and 3 as my vertex using my quick values. And now I'm going to use a little bit of strategy for selecting my next numbers. Because I do have this a value of a negative 1/2 multiplier, I'm going to take numbers that I know I can take half of. So things that are 2 away. So I'm going for 1 and 3, negative 3, and negative 5. If I substitute in the value of 1, 1 plus 1 is 2, whose absolute value is 2. Half of that is 1 with a negative, so negative 1. Negative 1 plus 3 is going to be 2. So, starting my graphing, negative 1, 3, and then I move to positive 1, 2. And I get these as my starting points. Next, substituting in the 3. 3 plus 1 is 4. Absolute value is 4. Negative half times 4 is a negative 2. Negative 2 plus 1 is simply 1. So I end up out at 3, 1. And if I were to continue, I would end up with a line that is relatively like this. Now as I move to the left, negative 3 plus 1 is a negative 2, whose absolute value is 2. Half of 2 is 1 with that negative sign. So negative 1 plus 3 gives me an answer of 2. Now with the negative 5 plus 1 is negative 4. Absolute value is 4. Half of that is 2 with a negative, plus 3 gives me simply 1. And I now have items to the left of my vertex, and I can turn it around. So you can see we have different transformations happening. Because my a value was negative, it turned my graph upside down. Because my a value was also less than 1, when we look at its overall value, the slope became a lot shallower. My slope on g of x was a lot steeper, and so we had an a value greater than 1. Going for our last graph here, we are going to speed up the process a little bit because we've seen several of these, x and y, but we do have the extra thing of what does it take to make inside this group 0. So I'm going to pull it to the side and say 2x plus 4 has to equal 0. So 2x has to equal negative 4. X would have to be a negative 2. So then, picking other points to go with that. And now, running it through, negative 2 times 2 is negative 4. Plus 4 is 0. 0 plus 3 is 3. So I have negative 2, positive 3 as a point. That's going to be my vertex. Now using the 1, or negative 1, negative 2 times 1 is negative 2, plus 4 is 2. 2 plus 3 is 5. And 0, 2 times 0 is 0, plus 4 is 4. 4 plus 3 is 7. Going the other direction, negative 3 times 2 is negative 6, plus 4 is negative 2. Absolute value is 2, plus 3 is 5. And our last one, negative 4 times 2 is negative 8, plus 4 is negative 4. Absolute value is 4 plus 3, again gives us 7. So we're here, and we end up with this. Now the slopes on this look very identical to g of x, and that's simply because with our multiplier inside, this 2 acts as a horizontal compression. It makes it narrower. The 2 on the outside before, for g of x, was a vertical stretch, so it made it taller. Narrower and taller end up having the same results. So look over your absolute values, make sure you understand how to find the vertex and build the table of values, and then we can graph.